Hello, today's video is going to talk about the second half of graph analysis, which happens to be given the graph of f, how do you find the graph of f? And we're actually going to take it even a step farther. We're going to be given the graph of f prime, and we are actually going to sketch a potential graph of f. Now, this is the back of the worksheet from the previous video. What the worksheet looks like, and this is what we filled out on the previous video, and it talks about the relationship between the graph of f and the graph of f prime. Now we're taking it in the other direction, and this is the way that calculus usually takes it. They give you the graph of the derivative and they ask you lots of questions about the original function. They either ask you to graph it or they ask you questions about it. So what we're going to start out doing today is going from a graph of f prime and getting a very rough sketch of the graph of f. Now, if you look at the directions of this tells you that this is the graph of f, and they ask you to sketch the graph of the derivative. But we're going to change the directions for the use of this lecture. We're going to mark this out right here, and we're going to say this is the graph of f prime, sketch the graph of f. This is the graph of f prime, sketch the graph of f. Now, some teachers have the kids sketch the graph of f over the graph of f prime. I think that's just too complicated and too confusing. So we're actually going to sketch the graphs of f on a separate sheet of paper. So I have some paper right under here. Okay, now we have our paper in front of us. We're going to go ahead and label this 7A. We're going to draw an XY grid, an X and Y axis. When we label this, the graph of the x-axis of f prime should match the graph of f, but we're not going to label the y-axis because there is just too much variability in where the points can go. -2, -1, 1 and 2 are the only points we need to label. Off to the right, I'm going to draw my number line just like from the previous lesson. I am going to make it rather long though because there is a lot of change in this graph of f prime. So draw a rather long number line for f prime, and then we're going to give the f information underneath. Okay, in the previous lesson we talked about the fact that there's a relationship between where f and f prime increase and decrease, etc. And so let me go ahead and just review that real quickly. This is our key to doing this problem. At any x equals c, if f is increasing, f prime is positive or above the x-axis. If f is decreasing, f prime is negative or below the x-axis. This lesson we looked at where the graph itself, that was f, was increasing and decreasing. Now for this graph, we are looking for where f prime is above or below the x-axis and marking it on here. So, taking a look at this graph, is this graph starting out above the x-axis or below the x-axis? Well, as you can see, it is above the x-axis, so I'm going to put a plus sign to show that it is positive at first, until I get to this value right here. Now, I don't know exactly where that value is. I'm going to just estimate it's about -1.3. Okay. After that, the graph is below the x-axis, which is negative, until I get to here, which is -0.5 approximately. Then the graph is above the x-axis again, so I put a plus until I get to positive 0.5 because it is symmetric. Then it is negative again down here until I get to -1.3, and then it is positive again. So this is the pattern of positive and negativeness for f prime. So now, using my key, I'm going to put on here where f is increasing and decreasing, and I'm going to use a different color just to make it stand out. So if f prime is positive, then f is increasing, then decreasing, then increasing, decreasing, and increasing. Okay. On the previous number line from the last video, we also put that c was either 0 or did not exist. And that can be helpful when drawing the graph of f as well. Do all of these points where it changes from positive to negative have a y value of 0? And the answer is yes. So I need to put zeros right in here. Okay? Now, remember that these are not y values for f. They're y values for f prime. What these are, though, are should look. If you go from a graph that is increasing to decreasing and it has a slope of 0 at the turnaround point, that usually means it's a pretty little hill, like this. This is a piece of graph that is increasing, has a slope of 0, and then it's decreasing. Now, that's not what this is talking about here, but that's an example of this kind of a situation. If it is an increasing and decreasing with a DNE, you might have a cusp or a sharp corner that occurs on your graph instead. So if you see zeros for all of these coming from the fact that this graph is crossing the axis 4 times, you can just know that this is going to be a nice little curve with pretty little hills and valleys in between the increasings and decreasings and so on. So from here, how you sketch the graph with the information that's given is really up to you as far as how high and how low you go. So this tells me I'm supposed to start out increasing. Now, because the graph is curved on the derivative, the original graph is going to be curved as well. So I'm going to start out increasing, but I'm supposed to stop increasing at about negative 1.3. So just pick a point. I'm going to pick about, right there. So I'm going to make my graph increase to there. Now the graph is going to decrease until I get to negative 0.5, at which point it's going to increase again. So I'm going to make this stop decreasing. Maybe right on the x-axis, just for fun. So this is supposed to go down, and it's supposed to kind of do a little curve because it's supposed to be smooth, remember? Then it's supposed to be increasing again until I get to positive 0.5. So I've got to be above where I am. I could be way above, just a little bit above. It doesn't really matter. I could be straight across from this one if I wanted to, right there, because I don't have enough information yet to know for sure. Okay, so that one's increasing. Now it's decreasing to negative 1.3. So negative 1.3, I'm going to decrease, maybe down to there. So I'm going to come down and kind of swing around. And then I'm supposed to be increasing after that, and that's it. So increase, and off we go. There's my graph. Now, that is a very, very rough sketch of what it could look like. Once we learn about second derivatives and concavity, we can find out exactly how it's going to turn and twist. So that is the graph for 7a. If this is the function, that's what the derivative is going to look like, and vice versa. All right, letter B. If I move the paper up, you're going to get B cut off. So I'm going to change the way this looks, and I'm going to move B out to the side here, like so. I'm going to draw my x and y axis. I want to go from negative 2 to 2 again. And I'm going to draw my number line for f prime and f. F prime and f. Okay. Now this looks kind of like one of the ones that was on the front of the worksheet, except it's going the other way. That's okay. So now, remember that I'm looking at whether this graph is positive or negative. And as you notice, this graph is positive everywhere. So in reality, I could put a big fat plus sign right here. But I'm going to go into a little bit more detail. What I want to do is think about the fact, how are the positive values changing? Are they getting bigger or are they getting smaller as we go? They happen to be getting bigger. So I'm going to draw this a little bit differently. I'm going to draw plus signs slowly getting bigger across the page to show that it is getting larger and larger positive values. Okay? So, yes, positive up here means increasing for f, but because this is curved, I know it's not a straight line. It's going to look one of two ways. A graph can either increase looking like this, or it can increase looking like this. Now, which one do you think it is based on these symbols right here? Remember that this positive means increasing and increasing and even increasing more and more and more. It happens to be this one because the slopes are slowly getting bigger and bigger and bigger and bigger, just like these values are getting bigger and bigger and bigger. Because remember that the y values on here correspond to the slopes on my original graph. So that means that this graph has to be always increased, and it happens to also be always above the x-axis. Okay. So this is one of those rare instances where the graph and its derivative look exactly the same, and there is a function that does fall in that category, and we will learn it later on in this course. And that's a nice one because it's easy to take its derivative when you're looking at the equation. Okay, letter C. Here's letter C's graph right here. So letter C will be a little bit longer on the x and y axis. So 2, 4, 6, negative 2, negative 4, negative 6. And then I need to draw my number line. It's imperative that you label your number line f prime and f. It's kind of off the page here, but I'm showing you because when it comes to AP, it's very important, and it's also, we're going to introduce an f double prime pretty soon, which is going to make a difference as well. All right, so remember this is the graph of f prime. So what are we looking for again on this graph? We are looking for where this graph is above and below the x-axis. So on the f prime line, what should I write first for this piece of graph? It is increasing. I don't care. What I care is where is it? It happens to be below the x-axis, so it makes it negative. And it stops being below the x-axis approximately at negative 1, at which point it is equal to 0. And then after negative 1, it is above the x-axis for this big hill until we get to positive 1, at which point it is 0 again, and then it is negative. Okay? So that means that since f prime is negative, f is decreasing, and then it is increasing, and then it is decreasing again. Now once again, because it's going through 0 on both of these, that means it's going to be pretty smooth. Okay? So now when we draw this, we know it's supposed to start out decreasing until I get to negative 1. So negative 1, I'm going to decrease until, let's just stop at the x-axis. So decrease to negative 1, and it's supposed to be smooth because it's supposed to have a 0 slope when I get there. Then it's increasing to positive 1. So it's got to be, I got to pick a point that's higher. I'll pick it right there. And then we're going to be slope of 0 again. And then it's decreasing after that. So down like so. And there is a rough sketch of what C could look like. Okay. All right, now letter D. Move that up just a little bit more. There we go. Letter D. One, two, three. 1, 2, 3. In both directions. Number line is next. F prime and F, which you can't barely see off the screen. All right. What do I write first and where for this piece of graph? Do I write increasing or do I write negative? This piece of graph is both, but I'm concerned about the fact that it is negative until I get to, and then it is positive after that. So that means that F is decreasing, and then it is increasing. Now, didn't talk about whether to put a 0 up there. Is that a 0 or a D and E? Well, it's looking like it's getting pretty straight up and down, but that doesn't matter. What matters is the derivative's value at 0, 0? And the answer is yes. So that gets a 0, 0. Okay, remember that that 0, 0 does not mean I have to go through 0, 0. What it means is that when I connect my increasing and decreasing, it's supposed to have a slope of 0 at that point. Okay, so this one, I'm going to make it decrease. I'm going to make it stop right at the origin. Doesn't matter where. I did 0, 0. Could have been below the origin. Don't know for sure. And then we end. And I just happen to make this one wide. I happen to know what this graph is, and I happen to know what its derivative is. I mean, what its original equation is. So I happen to know that this one tends to be very wide. The one thing that you just need to keep in mind is that your answer is correct if you make it parabolic shaped. Wide and narrow doesn't matter, as long as you bottom out at 0 comma something. It could be 0, -2, it could be 0, 5, it doesn't matter. So this is just a scratching of the surface of the relationship between the graph of f prime and the graph of f. And what you need to remember is that when f prime is negative or positive above and below the x-axis, that's what you look for. And then that translates to f increasing and decreasing, and then you draw that in accordingly. Later on in the course, there's a video called Graphing Working Backwards that goes into much more detail as to how to know how does this decrease. Does it decrease bowing up? Does it decrease bowing down, etc.? And there's a real nice way to figure that out, but you must understand how concavity works first. So right now we're just kind of doing a little bit of it, and then we're going to come back to it later on in the course and talk about more detail. Thanks for watching.